Hello everyone, this is the ECE550, the last project. It's about that fixed lock loop, and we create a project with that seamless with that you control that inverter and use that rubber just control that inverter seamless connect to the grid. So for that fixed lock loop, I use the STV functions and create that simulink. For the first one, this is to send in signals. So when the first one is that the send in signal is the amplitude is 10. The second one is 8. So after 2 seconds, the signal will be changed to drop 20%. And then this is the result. After about 1.3 or 4 seconds, the fixed lock blue is get that signal, voltage signal. Then at 2 seconds, the second signal send in, so it will, and then it catch that voltage information as soon as possible, so we can see that change really it will catch real faster. Then is the second one for the fixed loop. For this time the frequency first time is 60 Hz and the second will be the 59 Hz. So this is the output. So we can see it's still same at the 1.3 or 4 second. We catching that signals, and we can see right here it will be a little bit cost that 1-2 seconds. The new signal sent in, and that frequency has been little change, and that signal can catch up as soon as possible. And the last one is about the phase change. For that first one is the frequency 60 Hz, but the phase is the pi plus 1/3, and the second one is just phase is pi. So then for this one is still same. The signal catch up at 1.5 seconds, and that signal has changed and the phase has changed, but then it catch up. So that's the fixed lock loop. Then it's about that the whole signals that use that fixed lock loop connect to the grid and use the robust drop control to control that inverters. So for the right hand side is that grid, and it's a voltage source. Measure that one. It's a catch up that grid voltage informations. So then I send these values go into right here is that robust drop controls. So I give it the ins, use the RMS values to send it into the robust drop control, and this is the inverter voltage, and this is current. So after sending in, so it create kind of like look likely that stable grid voltage source. Then it sent to that and it create with this one and create to that PMW values, and so we can see that the created PMW values. So this is then is the output voltage. It is catch up at 100. So because that controller breaker controls for that when at the beginning that grid didn't connect to the inverters, at the 0.5 second it connect to the grid, and at 1.4 second that grid disconnect to the inverters, and this is control for the load. It will connect to the grid on the inverters at 1 second. So this is totally fully about that inverter's voltage. So we can see at 0.2 second, the voltage because that phase lock loop signal send in, we catch up the voltage, and 0.5 it's a little bit it has a little bit change for that right here, because that grid connect into that into the inverter, so that we can see that voltage source can be a little bit better. And 1 point right here, we can see that at 1 second we can see that load connect into the inverters, so it's nothing changed. Then it's about that 1.2 seconds that grid disconnect to the inverter. So but there is nothing big change for that voltage for that output. And then is the last task. It's about we use the PV arrays to control that, to give that as a DC source. So actually right here is I give the constants the sun values, and this is temperatures. Then I use a dial to make it stable, create a stable voltage, and I use that voltage to create a control voltage source and give that stable voltage source. Then it's about, so for this one, so that there'll still be here a phase lock loop, so it catch that signal is still same. Different things is that because that PV array is not stable as much as the last one, it need more response time. So for right here, we can see it is almost catched up that with a grid voltage source after almost kind of like the 0.5 seconds. So that is the signals, and send into here to create that PMW values right here. So it's still same for that step for right here, so we can see. And this is the output voltage. Yes, so it almost catch up at 0.5 seconds before the 0.5 second. So I still here that 0.5 second that connect to the grid, it's work seamless, and 1 second nothing change, and 1.3 seconds it change for that disconnect grid. It's a little bit just change. So that will be all.